Yesterday you watched a short video that explained or the understanding of how to graph a basic sine and cosine function. And for sines, it really had 4 steps. It started here, so this is kind of like step 0, and then it went step 1, step 2, and this should have been rounded. Step 1, step 2, step 3, and step 4. So it went through and had an intercept here, and intercept here, and an intercept here. This was the maximum value, and this was the minimum value. Now, when you're looking at your unit circle right now for me, please, I want you to go to the starting point and put your finger there. So please go to 1, 0 on your unit circle. Remember CBS, cosine before sine. What is the value of sine at that starting point? 0. Now please go to pi over 2. Put your finger on pi over 2 in the unit circle. What is the value of sine? 1. Now put your finger on pi. Find pi. On the unit circle, find pi. What is the value of sine? That's why we're here. We have another intercept. Please go to 3 pi over 2. 3 pi over 2. What is the value of sine? And go back to 2 pi. And what is the value of sine? So that's how we come up with these. These are increments that are equal distance apart. This is the most basic. This is one cycle. This describes the parent function y equals the sine of x that has a period length of 2 pi. So to do one cycle, it takes 2 pi. And this does continue to go on to the left and on to the right. It's a wave. It goes up and down and up and down and up and down. It looks just like this. It's like if we could take this and make a stamp and stamp it to the left and stamp it to the right. Okay? That's the most basic. Now today, we're going to jump in and do a much more difficult problem. And most of you took time to write this down on the board. And in this problem, it's going to have a basic function like this. So we're going to start, this is a C, excuse me. We're going to start by identifying what is the A, the B, the C, and the D of this function. So A is equal to 3. B is equal to 1/2. Not 1/2 x, it's just the number that's attached to the x. Doesn't include the x, so it's 1/2. C is 1 pi over 4. And D is equal to -5. We'll be referring to that today as we go through these. Okay, the first list there of things we have to identify is the amplitude. The amplitude describes a distance, and distance is always positive. So the amplitude is equal to the absolute value of A. The absolute value of A is equal to 3. Just to give you an idea of what that's going to look like when we eventually graph this, that means the distance from our center line, in this case it's the x-axis, but the distance from the center line that includes our intercepts up to the highest point, and the distance from the center line to the lowest point will be a distance of 3. Again, distance is always described as a positive number. Absolute value makes it positive. The second thing on the list is to identify the period length. So this particular sine curve, which is the parent function of a sine curve, has a period length of 2 pi. So to do this basic shape of, I'm going to go up the hill and then down in the valley, takes a distance of 2 pi. Sometimes it does that exact same shape, but it does it really fast. And other times, it takes a really long time to make that shape. So we're looking at what is the distance from the start to the end to go intercept max, intercept min, intercept. To figure that out, we're going to take 2 pi and look at the board. What are we going to divide by? 2 pi divided by what letter? B. And our B is 1/2. And now some of you can do that in your head, but what I'd like you to do is to grab your calculator and forget about the pi. Forget about the pi, we'll attach it on in the very end to the answer. Take 2 divided by 1/2. Feel free to make the 1/2 into a decimal. 2 divided by 0.5 is an answer of, I'm getting different answers from you, 4. 4. Remember, if you type in 1/2, it has to be in parentheses. Please make sure all earbuds are out. So this is an 4, and now we're going to reattach the pi. It's important we do that. Please, Ms. Rodriguez. Okay, so what does that tell us? It tells us that for our equation that we will graph eventually, that it won't take 2 pi to make the shape. It will take a distance of 4 pi. Bless you. This one doesn't turn on. Okay, the next thing we're going to do, look on the board. What is the next thing on the shift? It is center line. So our center line for this problem is the x-axis. That's not always going to be the case if there are shifts. So to get the center line, we take y equal to d. So in this case, it's y equal to -5. And this tells us what type of vertical shift is happening. So vertical shift, and we can put that into words. Vertical shift is we're going to shift this down 5 units. So instead of having the center of our graph be the x-axis, this center, the center line, instead of being the x-axis, will now be the equation y equals -5. We're shifting this whole thing down 5 units. All right, the next thing is going to be the maximum value and the minimum value. Take whatever this number is here, -5, write it underneath each, please. And we are going to add and subtract the amplitude. That will identify the y value that represents the maximum value and the y value that represents the minimum value. So I'm taking this 3 and I'm just going to draw a little arrow so we know where this is coming from. And I'm going to go +3 and -3. That means the maximum value will be -2. And the minimum value will be -8. Phase shift. Phase shift, let's first do the increments. I think that's just a little bit easier, and then we'll do phase shift and starting point. So I know they're not written in this order, but I'm going to write down increments. And just so you understand increments, we're going to take the period length, which is 4 pi for this problem, and we're going to divide it by 4. We always, always, always divide by 4. So I'm going to just draw a little arrow here and write always. The number on top may change, and that will depend on, for each particular problem, what is the period length. So if you come up here and you look at increments, what this is referring to is, if this is 0, so I'm going to do a 4 count. This is 0. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. What is the distance along the center line to get from 0 to 1? What is this distance? It is pi over 2. And to get from this step 1 to step 2 is pi over 2. And step 2 to step 3 is pi over 2. They will be equal distances. So that's describing the increment. So in this case, when you reduce, we get an increment of 1 pi. Now I'm going to move on to the 2 last things, which would be your starting point, and it will also be your phase shift. So I'm going to write down phase shift, and I do want to let you know, I would like you to put in parentheses if it's not on the board, write horizontal shift. So this is describing when we get a starting point, have we shifted it to the left or right based on this. And to get this, we are going to get this phase shift, how are we going to get that? So look over to the board to your left. We're going to take C divided by D. C divided by D. So our C value is 1 pi over 4. And we're going to divide that by D, which is, C divided by B, excuse me. C divided by B, excuse me. And we're going to divide that by 1/2. Please forget at this time, C divided by B, just to correct myself. Please right now, forget about the pi symbol. Using parentheses, please take 1/4 divided by, in parentheses, 1/2. Go ahead. And you end up with an answer of 1/2, correct? Now we're going to reattach the pi to that. So write 1/2 pi. And I'd like you to circle that. Now we need to determine, is that 1/2 pi, am I shifting that to the left, or am I going to shift it to the right? So to do that, we're going to write down starting point, our last thing. Then we are like 85% done with this problem, and we can begin graphing. Starting point. To do that, take whatever was in parentheses. So it was 1/2 x plus 1 pi over 4, and set it equal to 0. This was in parentheses behind the sign. 1/2 x plus 1/4 pi, and set it equal to 0. Now in solving this, the first step I'm going to do is I'm going to subtract the 1/4 pi. It moves across the equal sign and becomes negative 1/4 pi. And now to isolate the x, I'm going to multiply by the reciprocal. And although we say the 2's and the 1's cancel out, they disappear, really, what do they turn into? They turn into the number 1. So I have x equals negative 2 pi over 4. The negative 2 over 4 reduces to an answer of negative 1/2 pi. What does this tell me? It tells me when I go back up here that I'm going to need to shift to the left. Why to the left? Because this value is negative. I'll let you write that down on your paper. Jose, it's important you have this all done. Against the wall? You got it. Just blank. Does anybody need more time to write this down before I move on? Okay. All right, here's your next thing. So before we actually start graphing, let's just go over this again. I want to review the basic parent function, the video we reviewed. Remember, it starts here at what I call an intercept. I'm just going to use an I for intercept. Listen up. So it goes intercept max, intersect min, intercept. It's 4 steps. It starts at 0. This is not 1. So it's 0, 1 high, 2 intercept, 3 low, and back to intercept. All right. So before I graph on an actual graph, I'm going to just write this down. Let's start with 0. Okay, and there's 1, 2, 3, and 4. 0, 1, 2, 3, and 4. Please do the same. What was the starting value that we were able to come up with? It was negative 1/2 pi. And the increments that we came up with was 1 pi. That means to go from 0 to 1 and 1 to 2 and so on. Each time you're going to add 1 pi to that. Now I could, realistically, I could take out a unit circle and show you what that looks like. Or we could do this pretty simple way. We're going to grab a calculator. We're going to type in parentheses negative 1/2. Do not add a pi at this time. And we're going to add 1 pi. So please add 1 to this. Turn it back into a fraction. And that is equal to 1/2. So this is 0. At 1, we're at 1/2 pi. Add 1 again. Turn it back into a fraction. And now we're at 3/2 pi. Keep doing the same. Add 1. Turn it back into a fraction. We're at 5/2 pi. And add 7/2 pi. I'll let you get caught up. Okay, you ready? I want you to go back to here one more time. Remember your steps. This is 0, starts as an intercept on the center line. So intercept high, maximum, intercept max, intercept min, intercept. So over here, I'm just going to do that. Intercept max, intercept min, and intercept. Please do the same. getting close to being done here. Okay, so we are now ready to graph. So I'm going to start by taking these points, and I recognize that 0 is right in between. So I'm going to call this, they have to be equal distance. This is -1/2 pi. Equal distance, this is 1/2 pi. Equal distance, 3/2 pi. Distance, 5/2. And 7/2. This is one cycle, one period length. The center line was the equation y equals -5. So find where y is equal to -5. And I'm going to draw a dotted line representing the center line. Then I'm going to refer back here. So I find -1/2, and I have to remember that is an intercept on the center line. I make a dot. Then I go to +1/2 pi, and it says that's the maximum value. Please look back to your paper. What is the maximum value? The maximum value is -2. So at 1/2 pi, go up to -2. 3 pi over 2 is an intercept on the center line. 5 pi over 2 is the minimum. Look back to your paper. The minimum value is -8. And 7 pi over 2 is an intercept. So that's just one cycle of this. It doesn't stop there. It continues to make this wavelength as it goes to the right and to the left. It's as if we could take this as a stamp and we continue stamping it to the left, connecting it, and continue stamping it to the right. Okay? So let's talk real quick about domain and range. Is there any limit how far this goes to the left? No. Any limit how far it goes to the right? No. So our domain is -infinity to +infinity. The range, it goes down as low as -8, and it does touch at -8. It goes up as high as -2. So it does run from -8 to -2.